Pointers, positions. All right, so, I grew up on pointers, and I think pointers are great, but for some reason, this whole thing is trying to say pointers don't exist. What exists instead are positions, and I don't really understand why we bother doing all that, but somehow it abstracts it somehow. All right? So, and again, there's a textbook, and I guess it must be the textbook that is listed at the beginning, because when I first made these slides, I scanned some of the pages and put them up here, so you can read about this stuff more if you want more. Oh, somebody asked me about should you buy the textbook, and some people are readers of textbooks, and some people aren't. I personally have never read a textbook in my entire life. Some people go to class and look at slides, right, or whatever works for you. So you'll have to decide whether, so what is true is I don't put anything on an exam unless I can find a slide in which I taught it to you, right? And the advantage of the slides is I know what I've said, right? In fact, not only if I say something and it's not on the slide, then it won't even be on the exam. If it's not on the slide, I won't test you on it. All right? So now some people find that they like reading the book and some people don't. So all right, positions. So we're going to abstract. We're not going to think about pointers, or we're going to talk about this abstract thing called a position. And right? And what are they for? The concept is, you have fingers. Fingers are they look like pointers to me, right? But they're positions in the pie, right? You have a big data structure, and we want to have positions stored in the pie, right? And probably what they're pointing at, remember we talked about at the bottom, there were these elements, or these objects, or these nodes, right? Remember, they had the picture of my social insurance card, right? And that is the bottom object that we're pointing at, is our positioning, right? So we have positions there. We can have pens and a map. We can have little girls dancing, right? I like the little girls dancing. So here you got it. We have an object is this tree, and when I made this slide, Google. I love Google. You search for something, and it gives you all these things, and you download them. So I don't know what I searched for, but it gave me little girls dancing. So I put them there. All right, so there they are. There's what's special about them. They're a position. They're telling you, they're on a particular node, right? Right there's me, right? I'm in a position in the list, right? And we have variables that are of type position, right? So here this little girl is a variable. Girl 1 is a variable of type position, and currently her value would be this node, right? What position does she have? She has this node, right? And what can we do to them, right? Well, we can say, hey, we have the entire tree, and we have an operation child. And what does this operation child do? Well, it takes his input. In fact, maybe we go through it here. Here we go. We have an object, which is the whole tree. It has a method, a routine called child. What is that routine? It takes as input a position girl 1. And that's, I forget which one's girl 1. I think it might be her. One of them, right? Is an input. And it takes an integer as input. Which in this case tells you which child do I want to go to, right? Because this node has a number of children. It has 3 children. So if you're going to tell me move to my child, then you have to tell me which child to move to, right? So we're going to say move her to her first child, and so now it's returning the position of the first child, right? So we pass in her current position. And what this thing does is it returns the position of the child. And then we put here the code is putting the position of the child, the position into the same variable, right? So effectively what it looks like is that she's moving, right? She used to have the value here, and we gave child the value of here, and what it did is it returned the value here, and she now has that new value, and so she effectively moved. Right? Everybody buy that? Yeah? Any questions? Does that mean everybody understands? All right, good. Well, this is an abstract concept. They could be cherries in a pie, right? I'm just giving you an example, right? A position is a position within a data structure, and that could be pins in a map. It could be cherries on a pie. It could be nodes in a tree. And what do you want to do with a position? Well, you want to know where it is. You want to be able to walk around. You want to, right? All right, so here, the same idea. We moved her from where she was to the next sibling of where she is, right? And now she has the value of her next sibling, right? And now we move her from where she is, we did it again, her to her next sibling. And on this guy, this little girl, we set her to be the root, right? So here, tree, the data structure tree has a routine that returns the root position. And there she is. She's now the root. Right? Everybody good? All right. So, again, as I said, when I first passed through these, I just let them go. And then I came back and I understood them better. Right? So, question mark here. We're going to try to understand what this is saying. All right. So, remember, it's an interface. So, it's not going to have actually any code. It's just good. We're going to name some things and what, we're really not going to name much, right? It's called a position. What is a position? You were asking, is it a node in a tree? No, it's an E. It could be a cherry in a pie. It could be, right? We don't know what it is. It's an E. And all right? It's an interface, so it doesn't actually code. It's not actually implemented. What is it pointing at? It's pointing at, this is saying, actually, this is saying that this is sort of an input. We could do whatever we want with it, right? And in this case, what we're doing with it is we're telling you what a position is going to be pointing at, right? Or is going to be positioning, locating, right? It's going to be, is it locating a node in a tree? Is it locating a cherry in a pie, right? And so here, I guess the point is, there's this, right? Each position object needs to have some data, right? It's going to have some data E, which is where it is. It's what cherry it's locating or which node it's locating, right? And so then get element, right? What do we know? Oh no, I lied to you. I lied to you. All right? No, E is not the node in the tree or the cherry. It's the data contained in that. All right? So each location is going to have something that's there. So maybe the finger is positioning a place in the pie, and then what's there is the cherry that you find, or you have the node in the tree, and then you can get my name and my social security number, right? So E is going to be the data associated with the current location. No, that's what I first thought it was, and I think not. the girl is of type position, right? And if we said, girl, give me your data, then this node is containing something. Written in that node is some data. And so when she's here, if we say, give me the data at this node, we would get that data. But then if we moved her down here, then she would give me the data of that node. Right? So there's some data inside of each node. Right? This tree is not useful in itself. It's because it contains some data. Right? That makes more sense. We got a little girl down there. What are we doing down there? Oops. Yeah, so so then we're also storing extra things in this object, and those extra things will be the links between them, and so we know how to move between them, right? So I guess one of these objects here is, I guess I like to think about it as a node in the graph. You know, you're at this node, it has some data, and then there's some links to move other places, right? All right, so now what's this? Here we say a positional list. Oh, this isn't very exciting. It's just a list of these positional things, right? You don't just want one of them. You want a list of them. So there we got a list of them. And what can you do with them? You can iterate, just as we did before. If you have a current position, you can move to the next one in the list. And then the user, now we're writing code that's going to use this interface, right? So here's the cool thing is the interface hasn't even been implemented yet, but we're now going to be the user that's going to write code using that data structure that somebody later will implement, right? And what will our code do? It's just code you've seen before, right? Now the list is called, the positional list is a guest list, right? And so a position in the list is going to be a guest, right? And that guest is going to have various data associated with them, like what's the person's name, and right? And so we can talk about the first guest and getting what is the name of the first guest, and then we get the next guest, and we get the name of that guest. Right? Everybody kind of follow that? So this is just an example where you can write an interface that doesn't have any code, but hopefully there's some meaning that everybody knows, and then you can start using that meaning. Are people following this? Yeah? All right, well, holler, because we're just making it up as we go here. Right? So guest is a list of positions. And then each E is a type element at a position is now a specified string. Oh, here. So here somehow when we define guest, we filled in here that it's going to be that E is going to be a string, right? And that's going to be the name of the person. And so hence when we get element, it's returning a thing of type string, and so we're allowed to print it, right? If we'd said here guess was an integer, well, then it'd be returning an integer, and that wouldn't be a disaster because we know how to print integers as well, right? And so then the cursor, what type is cursor? Cursor is a position where, and again, it's a position where the element field is a string, right? And where do we get our first position? Well, guest, the list is a list things, and so guest is an object will have a method, and the method is called first, and what it does is it returns the first guest, which is the first position, right? Does that make sense? And yeah, I guess this is all can be either really easy or really hard, depending on whether you're getting it. Yeah? Yeah. Yeah, so guessed after, well then it's just like we were doing with the little girl, right? Cursor is on a particular guest, a guest who we already printed, right? And then this routine, right? Guest is the list, has a routine after, which what it does is you give it the position of one guest, and it returns the position of the next guest in the list, right? And then right, so, which cursor is now a position on that guest, right? And then if you say get the element, cursor get element, it then gets the name of that guest and prints it, right? And so then this is going to print all the names of all the guests. I think everything now is interfaces. We haven't written, they're just all interfaces, right? Nothing's implemented yet. This is our first piece of code, right? And who wrote this? It was the interface is kind of that line, and the data structure people are supposed to implement the code but haven't done it yet. And now the user is using this code without having it been implemented, right? And what did the user need to know to use it? Well, really, the user only needed to know that there were this concept of next, and trusted that after would eventually get you to them all, right? That your grammar won't be skipped, right? And right? It just needed to know these concepts so it could start writing code, right? So I guess the point is that here we made these very abstract interfaces, and now the user can go and start writing code using those interfaces, and independently the data structure designer can start implementing the code, and these two people don't have to talk to each other except via this interface, right? Does that kind of make sense? We're good? One of the bad things that happen is the people who tell me they understand are the people who understand. And nobody tells me, no, I don't understand. So if you're not understanding, it's okay to do something else. Are you understanding? There was somebody who had this, if you have a scared look, then I might look at you and say, are you understanding? Right? Because, the thing is, it only gets worse, right? You don't quite understand this, then we'll get to the next layer, and it'll be worse, right? And I would say, for me, there's two things that you need to understand on this page, all right? The one thing is sort of the concepts. Here there was the concept of the interface and separating out the two different sides. There's the idea of, and then there's the meaning of what is a position and a list. And then there's do you get all the notation, right? There's all these different layers. And any time I'm not going to know that I'm not expert at Java notation, and when I don't understand it, I'm going to ask him. And when you don't understand it, ask us both, right? Everybody good with that? I think we did. Did we do this? Oh, we talked about it at least, right? Here we get the first, cursor is getting the first guess, first guesses of type. What is a guess? The guess is of type position. Cursor is a type position, right? And then we get the next one. We move through the list. Cursor is moving down the list, printing out the names, right? And as we go, right, each step, the element stored in the cursor at the cursor position, the cursor is a position, and the data that's stored there is printed out. There it is, just repeated. I do think I stole these from somewhere when I taught it last, so they might be in the book. Is it Goodrich? Is that the book that we were supposed to That's even the name of the book? It might be. Anyway, it's evidently in section 3.7.3 of the book. Don't panic. We'll try to figure it all out. All right? All right, so all right, so now we have all these positions, right? And what do we want to do with them? We want to store them somehow. And we've seen already that we stored them in a variable, girl2. And we also sort of saw that you could store them in a list object. You can store them in an array. I guess I'm making this is more my slide, how I would do it. I'm saying, well, a position is just an object that you can store wherever you want to store it, right? You can store it in a variable. You can store it in an array. You can do whatever you want with it, right? And so we can say, hey, A2 is of type position. And what is A2 holding? A2 is holding this position, right? And A4 is holding that position, right? Does that make sense? And of course, as soon as you draw arrows, I want to say pointer, but we're not going to say pointer yet. We're just saying positions, right? Everybody good? What happened? We stopped. All right. So we're moving on to linked lists because we're going to, if you haven't seen this before, it might frighten you. Yeah? Uh-huh. Yep. 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 So here, this is where it gets kind of messy. All right? If you have, how many people aren't comfortable with linked lists? Is everybody else comfortable with linked lists? Or I always do this game. Who understands this? Who doesn't understand this? Who's panicking? It's the same. So let's talk about a linked list. All right? So each of these little boxes is going to be a record, right? And it's going to have two things. It's going to have data. Their info is the E. It's the data that's associated with it. But it's also going to store a position, right? It's going to have two things. It's going to have data, and it's going to have a position. And what's the position hold? It holds the next position in the list. So each of these objects, right? Well, it's a node, but it's also what's a position? A position is an object, or at least it's the name of an object, or it's the position of an object. It's the address of the object, right? Anyway, what the link does is it stores the next one, right? And so then you get this chain of them, right? Each element contains two fields, the first storing info, the second storing the position of the next object, right? So this variable here is of type position or of type pointer, right? All right, pointers. All right, so you've already got that I'm more of a pointer story, right? It's claimed that Java has no pointers, but really everything is a pointer. Right? Every object, integers are integers, all right? And real numbers are real numbers. Everything else is a pointer to something, all right? What is a pointer? It's an address of the object in memory, all right? And like in C is all about pointers. Actually,